Okay. First one, ED260 Chapter 3, Application of Differentiation, Graph of Polynomial Function. Okay, these are the two example of graph of polynomial function. Ini contoh graph dia lah. Kalau nampak graph ni, okay, the first example, increase, decrease, decrease, increase. The second example, decrease, increase, and then decrease. So what is polynomial function? A polynomial function is a function such as quadratic, cubic, quartic, and so on, involving only non-negative integer powers of x. We can give a general definition of a polynomial and define its degree. So polynomial function ni, contoh dia quadratic function. What is quadratic function? Quadratic function ni macam mana bentuk dia?
X square.
Betul, very good. Ax square plus bx plus c. So the highest power of x for quadratic function is x squared. What about cubic function? Kalau cubic?
X square, the power of 3.
Yes, very good. X power 3. The highest power of x is x power 3. So itulah dia polynomial function involving only non-negative integer powers of x. So dalam equation dia, kalau ada x, dia punya kuasa tu mesti positif. Contoh, if you have x power negative 2, is it polynomial function? X power negative 2 polynomial function ke tak?
No.
No. Okay, kalau x, let's say x power negative 3, polynomial function ke bukan?
No, madam.
No. Okay. Polynomial function tak kira lah quadratic ke, cubic ke, tetapi mesti non-negative integer powers of x. Okay, so to sketch polynomial graph of polynomial function, kalau kita nak lukis graph polynomial function antara maklumat yang kita perlu ada adalah number 1, x and y intersect. What is x and y intersect? What is x and y intersect?
Pintasan X and Y.
Betul. Okay, pintasan x dan pintasan y. Second, increasing and decreasing interval. Ini contoh yang saya kata tadi. Okay, we have two examples of graph of polynomial function here. Macam graph ni, dia mula dia increase. Increase tu dia naik kan? Dia naik. Turun. And then naik. Okay, ini yang kita panggil sebagai increasing and decreasing interval. Kita nak tahu graph tu dia naik dari mana sampai mana, and then dia turun dari mana sampai mana, naik semula dari mana sampai mana. Okay, that is the second info that we need in order for us to be able to sketch the graph of polynomial function. Third, critical points or extremum. Okay, nama pun critical. Okay, critical point ni ada dua. Sama ada maximum ataupun minimum. Okay. Maximum point or minimum point. Okay. Based on these two graphs, kita nampak ni. So this will be the maximum point and this will be the minimum point. Okay. For this graph, this will be the maximum point and this will be the minimum point. So that is the third information that we need. Critical points or extremum. Okay, there are two types, maximum point and minimum point. Okay, 4. Concavity. Concavity ada dua juga, either concave upward or concave downward. Concave ni maksudnya lengkungan. Okay, kalau concave upward, ke atas senyum. Kalau dulu kita belajar graf tu senyum. Concave downward, dia melengkung ke bawah. Okay. So nak tengok lengkungan. Like the first example, the graph starting with concave downward and then concave upward. But the second graph, dia upward dulu. Concave upward and then concave downward. Number 5, inflection point. inflection. Apa maksud inflection? What is inflection in Malay? Saya tak boleh nak recall pula. Tapi tahu inflection in Malay apa? Berubah arah. Titik di mana graf tu akan berubah arah. What is inflection? Can someone help me? What is inflection? No one? Can anybody help me, please? Inflection ni, I cannot recall exactly the meaning in Malay, but dia adalah titik di mana concavity ataupun lengkungan ni akan berubah arah. Contoh graf pertama tadi, mula-mula concave downward. Graf ni mula masam kan? Sampai kat sini, sampai kat tengah-tengah ni, dia jadi concave upward. So this is what we call as inflection point. Titik di mana concavity berubah. Kita tengok betul-betul graf ni, mula-mula masam. Sampai sini dia berubah jadi senyum. Okay, so this is our inflection point. From the second graph, mula-mula senyum. Sampai sini jadi masam. Okay, senyum, masam. So this is our inflection point. Number 6, then we can proceed to sketch the graph. So kat sini kita akan belajar beberapa perkara lah. How to find x and y intercept, how to find increasing and decreasing interval, how to find critical points or extremum, how to find concavity either upward or downward, how to find inflection point, so that finally we can sketch the graph. So itu macam kita punya matlamat lah, macam ni kita nak sketch graph of polynomial function. Okay, macam ni contoh graph. Okay, I gave you 2 examples of graph of polynomial function. Okay, setakat ni, any question? Apa yang awak nak tanya? Soalan?
Madam,
Yes.
Madam, can I ask one question?
Yes.
The term of inflection point is actually very rare for me because before this I quite it's not exposure to this kind of term. So is that possible for every kind of graph that consists with inflection point?
No, only for polynomial function graph. Untuk graph polynomial function sahaja. Bukannya semua jenis graph.
Oh, okay. Thank you, madam.
Is that your question? Did I answer your question?
Yes, thank you,
Yeah.
madam.
Alright, thank you very much for the question. Any other question? Dia tanya terus tahu, lepas ni kita akan pergi belajar macam mana nak cari ni satu persatu. So kalau dia nak tanya sekarang. Cikgu-cikgu sekalian, nanti nak suruh nak buat tanya soalan, cikgu pun kena tanya soalan. So no question? Can we proceed?
So far faham lagi, madam.
Alright, very good. Okay, number 1, x and y intercept pintasan x dan pintasan y. So to find x intercept, substitute y equals 0 into the given function. To find y intercept, substitute x equals 0 into the given function. Any question? Here. Misal saya rasa dah banyak kali awak jumpa. Masa SPM pun ada belajar kan? Tak ada masalah kan?
Okay, madam.
Right, proceed to the second step. Okay, how to find increasing and decreasing interval. Okay, f prime x. Apa maksud f prime x kat sini? If originally you have fx, but here we have f prime x. What does it mean?
Derivative.
Okay, so first derivative. Kita dah differentiate sekali. Okay, first derivative. If you get the value more than 0, meaning that the interval or the function is increasing. First derivative, the value is less than 0, then decreasing. Okay, to determine increasing and decreasing interval, here I give you 4 steps. Number 1, differentiate the given function. Kita buat first derivative. Differentiate sekali. Number 2, set f1x equal 0. First derivative tadi samakan dengan kosong. Number 3, find critical value. Critical value ni, tadi awak dah buat f1x equal 0, kemudian cari nilai x. The x values that you get, we call it as critical values. And then from critical value, we can construct this table. Okay, let's say we have two critical values, x1 and x2. The first column for the table is interval. Second column for the table is test value. And third column for the table is we want to find the sign when we substitute test value inside f1x. So, interval always start from negative infinity and ends with positive infinity. First interval, negative infinity until x1. x1 is our first critical value. Second interval from x1 until x2. Our first critical value, our second critical value. And then the last interval, our second interval value until positive infinity. Okay, let's say we have 3 critical value. Katakanlah kita ada 3 critical value. X1, x2, and x3. So our interval is always start from negative infinity. So from negative infinity until x1. Second interval, x1 until x2. Third interval, x2 until x3. And then the last interval, x3 until positive infinity. So kalau ada lebih critical value, kita akan ada lebih interval. Contoh kalau nombor, let's say our critical values are 1 and 2. Okay, let me call your name. Nah Tauqif Rushaidi. Can you please give me the first interval? Katakanlah x ataupun critical value kita 1 dan 2. Can you please give me the first interval? Nah Tauqif Rushaidi.
Yes.
Okay, first interval.
Negative infinity x1.
Negative infinity until
x1.
1. Okay, very good. Correct. Next, Aisyah Nadira. Can you please give me the second interval?
1 and 2.
1, 2. Okay, very good. And then Nur Wahida Emmeline, give me the third interval.
2 positive infinity.
Correct. And then I would like to ask Muhammad Haikal. Do we have more interval? Do we have the fourth interval? Muhammad Haikal.
Katakanlah dan
Mana nama Muhammad Haikal? Dah tak ada dah. Is Muhammad Haikal here? No. Then I change to Christopher. Are you here?
Yes, madam.
Alright, so do we have more interval?
Yes.
Ada interval yang keempat ke? Kita ada 1, 2, 3. Critical value x sama dengan 1 dan 2. Ada lagi ke interval lain?
No.
No. Okay. So when we have 2 critical values, we only have 3 interval. Always start from negative infinity, ends with positive infinity. So first interval, negative infinity until 1. second interval 1 until 2, and third interval 2 until positive infinity. Right, so should we try one more? Let's say our critical value x equal negative 3 and 0. Alright, let me call your name. Fakrul. Fakrul, what is the first interval?
Negative infinity to 3. To negative 3.
Alright, very good. Next, Farjin. Farjin Wanisha.
Yes, saya, madam.
Second interval.
Negative 3 to 0.
Alright, very good. And then one more. Nurul Auni Shahira. No, Nur Auni Shahira.
Yes, madam.
Hmm.
0 to positive infinity.
Okay, very good. Alright, so itulah dia. From critical values, for the first column, kita akan buat interval. Okay? The number of interval depending on the numbers of critical values. Macam ni, kalau ada 2 critical values, kita ada 3 interval. When we have 3 critical values, we have 4 interval. Okay, moving on to the second column. Second column ni test value. So choose one value within the interval. Kita akan pilih satu nilai, tapi mestilah dalam lingkungan interval. For example, first interval from negative infinity until x1. So our test value must less. The value must be less than x1. Contoh, kalau kita ambil sini, from negative infinity until 1, what is the test value that we can choose? Apa nombor yang kita boleh pilih?
0.5.
Okay, very good. Tapi tak perlulah 0.5 tu, ambil je 0. Okay, what else? 0.5 betul. 0 betul. What else? Give me one more example.
Negative 1.
Negative 1, negative 2, and so on. Okay, very good. Right, from the second interval. The second interval ni from 1 until 2. Give me one test value. One suitable test value for this interval.
1.5.
0.
Boleh 0 tak? Daripada 1 sampai 2, boleh 0 ke tak boleh 0?
Cannot.
Cannot.
No.
Cannot. Because the value must be within 1 and 2. Nilai dia mesti di antara 1 dan 2. Siapa yang kita boleh pilih?
1.5.
Okay, very good. 1.5. Okay. And from the last interval, from 2 until positive infinity. Give me one test value.
3.
3, 4, 5, 6 and so on. Okay, very good. Okay, kita buat yang ni pula. From the first interval, negative infinity, negative 3. Apa test value yang kita boleh pilih?
Negative 4.
Negative 4, negative 5, negative 6 and so on. Okay, from the second interval, from here, from negative 3 until 0.
Negative 2.
Negative 2. Lagi?
Negative 1.
Negative 1.
0.
Dah. Kan? Sebab lepas tu terus 0. Dia mesti di antara. Awak tak boleh pilih negatif 3. Awak tak boleh pilih kosong. Nilai di antara negatif 3 hingga kosong. So yang paling mudah kita ambil sama ada negatif 2 ataupun negatif 1. Okay, what about the last interval? 0 to positive infinity. What are the test values that we can choose?
1.
1,
3.
2, 3 and so on. So okay. First column tadi dah faham macam mana nak buat. Second column pun nak faham macam mana nak pilih. Faham? Okay.
Faham, madam.
Alright.
Faham.
Awak pilih sendiri tau. Dia tak tertakluk. Maksudnya kalau ni kosong sampai infinity. Ada orang pilih 1. Ada orang pilih 2. Boleh. Okay, it's totally up to you. As long as the value is within the interval. Okay, apa yang kita akan buat dengan test value ni? We will substitute the test value inside f prime x. kita akan gantikan nilai test value tu dalam first derivative yang kita dah differentiate tadi. Kita nak dapatkan dia punya sign saja. Okay, if the answer is positive or negative, when you substitute test value into f prime x, you get the answer. If the value is positive, you write down positive. If the answer is negative, you write down negative. Apa maksud positive negative ni? To determine increasing interval or decreasing interval. Katakanlah awak dapat positif. Okey, untuk yang pertama ni awak dapat jawapan positif, maksudnya this interval is increasing interval. If let's say you substitute the second test value, you get negative, meaning that this interval is decreasing interval. Alright, any question for increasing and decreasing interval?
No, madam.
No. Okay, let's continue. The third one. Oh no, not yet. Okay, kita tengok more explanation. Okay, the first derivative test. Suppose that C is a critical number of a continuous function f. Okay, kat sini dia guna C. Tadi kita guna X. Okay, tadi kita guna X je. Okay, kat sini C. C is a critical number. If f prime changes from positive to negative at C, then f has a local maximum. Kerana daripada positif ke negatif, dia akan jadi maximum point. Macam ni. Positif, increase kan? Dia kata daripada positif ke negatif, and then negatif, decrease. Point dekat atas, ini akan jadi maximum. Okay. If f prime changes from negative to positive at C, then f has a local minimum at C. Okay, tapi kalau negative to positive, mula-mula dia decrease and then increase. Okay, because from negative to positive, and then we have a local minimum. Okay, point dekat sini akan jadi minimum point. Here, local maximum or maximum point. Here we have local minimum or minimum point. If f prime does not change sign at C, for example, if f prime is positive on both sides of C or negative on both sides, then f has no local maximum or minimum at C. Tapi kalau dia sama, positif, kalau positif maksudnya dia increase and then dia increase lagi. Kalau negatif, dia decrease lagi. Okay, kalau increase or decrease, then we have no local maximum and we have no local minimum. Jadi mesti increase, decrease. Okay. Ini kita ada kat atas. Maximum. Kalau dia decrease, increase. So, point dekat bawah ini akan jadi minimum. Ini example yang increase, maksud increase lagi. Okay, this is the example yang decrease. Okay, kalau macam ni, no maximum or minimum. Anything you want to ask? Okay, let's proceed. So how to find critical point or extremum? From critical value. Okay, kalau kata point, dia mesti ada x coordinate and y coordinate. Okay, point. Point mesti ada x coordinate, y coordinate. Coordinate x is from the critical value. Y coordinate is when we substitute x is critical value, into the original function. Okay, again, kalau kata point, dia mesti ada koordinat x dan koordinat y. Betul? Tentu kalau nak plot kan? Kalau lah point awak tu 1, 2. So kat bawah ni 1, kat sini 2. So this is your point. Betul? Betul? Masih dengan saya ke dah hilang dah semua-semua ni? Are you still with me?
Yes, madam.
Alright, so boleh faham critical point mesti ada koordinat x dan koordinat y. Contoh, if your point is 1, 2, so X ini 1, Y sini 2. So this is our point. Betul?
Tu madam.
Madam.
Okay. Thank you for the response. Then, to find the coordinate of critical point X, the X is from critical value and the Y is when we substitute the critical value into the original function. The answer, here the answer when we substitute, that is our Y coordinate. So what is the difference between critical point and extremum? Okay, sometimes the question will ask you to find critical point and sometimes the question will ask you to find extremum. So you need to know the difference between these two things. Critical point, a list of points that has not been determined either it is maximum or minimum. Kalau dia just kata critical point, kita boleh senaraikan je. Kalau ada dua, dua lah. Kalau ada tiga, tiga lah critical point. Tak perlu bagi tahu sama ada point tu maximum atau minimum. But if the question asks you to find extremum, then you need to classify. Either the critical point is maximum point or minimum point. So again, critical point is just a list of critical points. Kamu senaraikan je. But extremum, you need to determine each of the critical points. Either it is maximum or minimum. Anything you want to ask from here?
No, madam.
Okay. Let's take a break. Kita rehat sekejap dalam 10 minit.
Okay, madam.
Hello everyone, can you hear my voice?
Boleh, Madam.
Right, let's continue. Number 4, concavity. Concavity, either concave upward or concave downward. Concave upward, melengkung ke atas, sebelah kita akan senyum. Ini macam ni lah contoh ni. Concave upward, ini graf senyum. Concave downward, graf masam. Sekejap ni. Again, concavity, lengkungan, concave upward, melengkung ke atas, sebelah kita akan senyum. Concave downward, melengkung ke bawah, kita akan masam. So here are the two example, ni upward, ini downward. Okay. If increasing decreasing interval, we're dealing with first derivative. For concavity, we will deal with second derivative. So, tengok sign dekat sini. This is the sign for second derivative. Maksudnya kena differentiate dua kali. If the value for second derivative is more than 0, then it is concave upward. If the value for second derivative less than 0, then concave downward. But the steps to determine concavity, first, kena carilah, you need to find second derivative. Kena differentiate the function 2 times. Number 2, the differentiated function equal to equal 0, samakan dengan kosong. Kenapa kita nak samakan dengan kosong? Because we want to find the inflection values. Okay, x equal x1, x2. Nilai dia x juga sama, cuma nama berbeza. Kalau first derivative tadi, the first derivative we call it as critical values. Okay, the values from first derivative is critical values. The values from second derivative is inflection value. Okay, and then from the inflection value, we will construct this table. Okay, table ni sama je macam previous table. First column is for interval. Second column is for test value. Okay, you choose test value within the interval. But the difference is only for the third column. Beza dia dekat kolom yang ketiga ni sahaja. Previous table, we substitute test value into f prime x. But for this table, we will substitute test value into f double prime x. Kita gantikan test value dalam second derivative. If the value is positive, meaning that is concave upward. If the value is negative, then concave downward. Inflection point. How to find inflection point? So again, point. Kalau point mesti ada koordinat x dan koordinat y. So the x coordinate is from the inflection value. Okay, kalau tadi critical point. Kalau critical point, x dia daripada critical value. Tapi bila inflection point, x ni daripada inflection value. Okay, how to find the y coordinate? To find the y coordinate, substitute x into the original function. X here is, kalau x tadi critical value, x dekat sini inflection value. Gantikan inflection value dalam fx. And that the value that you get is our y coordinate. So what is inflection point? A point at which concavity changes direction. Contoh, katalah mula-mula graf awak concave downward macam ni kan. Sampai kat satu point, dia tukar jadi upward. So this is inflection point. Ataupun kalau lah mula-mula dia upward, graf tu mula-mula senyum. Senyum, sampai kat satu point, dia tukar jadi masam. So this is inflection point. A point at which concavity change direction. Concavity test. Okay. Concavity test. If f double prime x more than 0 for all x, then the graph of f is concave upward. Okay, kalau more than 0, maksudnya concave upward, senyum. If f double prime x or second derivative less than 0, then the graph of f is concave downward. Graph kita akan masam. Definition, a point P on a curve y equal fx is called an inflection point if f is continuous, there the curve changes from concave upward to concave downward or from concave downward to concave upward. So kat sini dia explain now kat awak lah what is inflection point. Dia kata bila graph tu berubah daripada upward kepada downward ataupun daripada downward kepada upward. Ini yang kita dah discuss tadi kat sini. Ini downward dulu sampai kat inflection point jadi upward. This one upward dulu senyum sampai kat inflection point tukar jadi downward. The second derivative test, suppose f double prime is continuous near C. What is C? C is our inflection value. If f prime C more than 0 and f double prime C more than 0, then f has a local minimum at C. If f prime C equals 0 and f double prime C less than 0, then f has a local maximum at C. Okay. Kalau second derivative more than 0, okay, more than 0 ni concave upward ke downward? F double prime C more than 0 ataupun second derivative more than 0, upward ke downward?
Upward.
Upward. Okay, very good. Kita tulis balik. Okay, kat sini ada kosong. F double prime C more than 0, upward kan? Graf kita akan senyum. Bila graf senyum, point kat bawah ni akan jadi minimum. Ni sebab tu dia tulis ni. If second derivative more than 0, f has a local minimum. Sebab senyum, point bawah ni akan jadi minimum. If second derivative less than 0. Kalau less than 0, upward or downward?
Downward.
Downward. Point kat atas ni, ini akan jadi maximum. Okay, f double prime C less than 0, then f has a local maximum at C. Okay, example, discuss the curve y equal x power 4 minus 4x power 3. Look at this equation or function. Y equal x power 4 equal 4x power 3. Is it polynomial?
Yes.
Why? Why?
Because the integer is not negative.
Okay, very good. X power 4, positive kan? And then 4x power 3 also positive. So this is an example of polynomial function. Okay, discuss with respect to concavity, points of inflection and local maxima and minima. Use this information to sketch the curve. Original function x power 4 minus 4x power 3. First derivative differentiate sekali, you get 4x power 3 minus 12x square, or when you factorize, you get 4x square in bracket x minus 3. And then differentiate again to find the second derivative, f double prime x equal 12x squared minus 24x, and then you factorize, you get 12x in bracket x minus 2. Okay, do you have problem to differentiate? Can you differentiate well? Semua orang dah boleh differentiate dengan baik ke?
Boleh, madam.
Boleh, madam.
So kalau setakat function macam ni nak cari first derivative, second derivative, ada masalah tak?
Okey je, madam.
Okay je,
Ya, madam.
Alright, so from the original function, first derivative, second derivative. Next, to find the critical numbers, we set f prime x equals 0 and obtain x equals 0 and x equals 3. Okay, nak cari critical number ataupun critical value, kita buat f prime x samakan dengan kosong. Daripada situ awak akan dapat x sama dengan kosong dan x sama dengan 3. Ni f prime x. 4x square x minus 3 equal 0. So from 4x square equal 0, we get x equal 0. From x minus 3 equal 0, we get x equal 3. So these are our critical values. X equal 0 and x equal 3. Use the second derivative test, we evaluate f double prime at these critical numbers. F double prime 0 equal to 0. F double prime 3 equal to 36, which is more than 0. Since f double prime x equals 0 when s equals 0 or 2, we divide the real line into interval with these numbers as endpoints and complete the following charts. Ini dia buat table. The table is a bit different. Dia tak ada second column. Kalau macam yang saya ajar tadi ada second column, kita pilih test value. Okay, this one cuma ada interval. And then kita ada ni, ini untuk sign, nak cari sign, dapat positif, negatif, positif. So when positive, concave upward, negative, concave downward, positive, concave upward. This is the summary. The point 0, 0 is an inflection point since the curve changes from concave upward to concave downward there. Also, to negative 16 is an inflection point since the curve changes from concave downward to concave upward. Using the local minimum, the interval of concavity and the inflection point, we sketch the curve. And so saya tak ada graph dia. Okay, I'm sorry. Tapi ni cuma example lah. We will discuss more example later on. So we don't need